Welcome to homework.
To determine if there is a significant difference between the treatments, the control group, and experimental group, we can conduct an independent samples t-test. So we know with the control group that the sample size is 6, the mean is 63, and the sum of the squares is 1250. And in the experimental group, we know that the sample size is 6, the mean is 79, and the sum of the squares is 1750. So we need to calculate the pooled variance, the t-statistic, and compare it to the critical region at a significance of 0.05 for a two-tailed test. So first, let's calculate the pooled variance using the formula. The variance pooled, which is the variance is the standard deviation squared. And so that is the sample size minus 1 times the standard deviation squared plus the second sample minus 1 times the standard deviation squared over the sum of the sample sizes minus 2. The variance is the sum of the squares, which would be 1250 over the sample size minus 1, so that'd be 1250 over 5, which is 250. And the second variance would be the sum of the squares over the sample size minus 1, and 1750 over 5 is 350. So we've got 5 times 250 plus 5 times 350 over 6 plus 6 minus 2, which is 10. So the pooled variance calculates to 300. And next we can calculate the standard error using the formula. The standard error is equal to the square root of the pooled variance over the first sample size plus the pooled variance over the second sample size. And so that would be the square root of 300 over 6 plus 300 over 6. Which is 300 divided by 6 is 50. So that would be the square root of 50 plus 50, or 100. The square root of 100 is 10. Now we can calculate the t-statistic using the formula, the sum of the two means over the standard error. So that's going to be not the sum of the two means, the difference. That's going to be 63 minus 79 over 10, which is negative 1.6. To determine the critical region, we need the critical t-value for a two-tailed test at a significance of 0.05 with degrees of freedom of 10. That's 2 less than the pooled samples. And that's 2.228. Since the absolute value is less than the critical t, the data does not fall within the critical region. It's not less than negative 2.228. So we fail to reject the null hypothesis. Based on the given data in a two-tailed test at a 0.05 level of significance, there is insufficient, not enough evidence to indicate a significant difference between the treatments.